This session is on the subject of climate threat and adaptation. For those of you who don't know me, my name's David McLennan. I work for NatureScot, have done for a long time. In most of my career, I'm still based in the Outer Hebrides, but I've had a lead responsibility for our operational work throughout the Outer Hebrides. And that has left me closely engaged in the work that we've been doing with the Community Planning Partnership and Climate Hebrides on matters with respect to climate change. So I might have slipped off to do another job for a wee while, but I've still got my eye very closely on what's happening on climate change in the Outer Hebrides, and I've got a very keen interest in the work that you're doing. It is so good to see so many people together in this room this afternoon, and I know there's a lot of people online too. Really encouraging to see the level of interest that there is in climate change in the Outer Hebrides and what we really need to do to step up to the challenges ahead. I'm really looking forward to this session. I'm looking forward to hearing about and speaking about the challenges that we face from climate change. And importantly, what we need to do to get ready for that. I don't know if it's been mentioned already today. I slipped out for a couple of hours this morning, but it's 10 years since the Paris Climate Change Agreement was signed. And that agreement was aiming to limit the rise in global temperatures to no more than 1.5 degrees above pre-industrial levels. That's over a 20-year average. With current global trends, it looks like the direction of travel is towards temperature rises well in excess of that over the next 50 to 70 years. With every increase in temperature leading to increased uncertainty around what the impacts might be. We really don't know what the impacts are going to be, but there is increased uncertainty around them. We can already see extreme events taking place around the world, linked to changes in the weather. You'll all see this every day. Wildfires, storms, floods, droughts. It's not really news anymore. 20 years ago it was. It's just the norm now when we see things happening. So we can see things changing. I found it really good today to hear about so many things that are happening in the islands around minimizing our footprint. It's really important that we do as much as we can because every little thing helps address that global challenge. However, we know that even if all of the countries who signed that agreement 10 years ago actually stuck to their pledges, and we know they're not, we're still going to see our climate change due to the emissions that are already locked into the system. I thought it was interesting earlier today, Chris Stark talking about how climate change is seen very much as a global issue. But you really need to look at it at a local level, and I think that's what we're doing here. So, thinking about all of that, that means we need to plan. We need to think hard about what climate impacts we might see here, on our doorsteps. What are the risks to our islands and our communities? And what do we, that's everybody in this room, what do we need to do about managing these risks? We need to plan to adapt, and that's what we're going to consider in this session. And we've got 3 speakers this afternoon who are going to give you updates on what they've been working on. And then we'll have a question and answer session after everybody's had a chance to speak. So first of all, I'm going to introduce to you Marianne Ferguson and Amanda Vestergaard. Marianne is the Public and Community Engagement Officer for Muir, a partnership between islanders, local groups, and other climate initiatives and researchers in Barra and Watersee. Amanda is the field researcher for Muir. And thank you for coming up from Barra and Watersee for this event. The partnership develops nature-based solutions to coastal change that promote a flourishing ecology whilst mitigating the harms of coastal erosion. And their research generates knowledge on collaborative working between communities and environmental science researchers. So, Marianne, Amanda? over to you.
Fisker ma Karsten, mi dochas gwyl geolade vi acu. Bevalm torsach le tangehoid de lokoprach gna hietje in jelen sheer na in de Chicago son kudige hoidgine son vi showed Muir's Teeth is a research project looking at coastal changes in Barra and Watersee. It's a research project with a difference in that as well as undertaking scientific research, it's a partnership between islanders, local groups, other climate initiatives, and researchers from disciplines of civil engineering, agri-engineering, marine ecology, fine art, and anthropology. We aim to work collaboratively in order to build local resilience against the effects of climate change through nature-based solutions that promote a flourishing ecology whilst mitigating the harms of coastal erosion. The project has been funded by the Natural Environment Research Council, part of UK Research and Innovation, until the 31st of October 2028. Our sites, we're looking at 3 different sites, each with their own set of problems. We are looking at Borv Graveyard on the west side of the island on the Atlantic coast, Saltanish at Eolagurry to the northeast of Barra, and Watersee to the south. The graveyard at Borv is believed to be the site of one of the first Christian settlements on the island, dating back to at least 700 AD. It's therefore not just a place of social importance, as generations of many families rest there, it's also a site of archaeological significance. The issue here is that a section of the graveyard wall is affected by erosion caused by the strong Atlantic waves. Eolagurry Beach to the northeast. The dune systems of Eolagurry Beach in the northeast of Barra have seen significant erosion in recent years. This area differs from Borv in that it is part of a dune system and there are frequent changes to the landscape as the dunes move. However, there is now evidence of erosion that is impacting on crofting land. Watersee Bay is a tombolo that joins the 2 sections of Watersee Island. The Atlantic lies to the west and the Sea of the Hebrides to the east. The dune systems in Watersee Bay have become less stable as a result of extreme weather, and there's a real danger of flooding if the west dunes collapse. The area is also a busy tourist attraction throughout the spring and summer.
All right, so as most of you are probably aware, people in the Western Isles have a long history of living with and adapting to coastal change. But what we're seeing now is that there's a significant increase in the pace at which this erosion is happening. It's estimated that since the 1970s, there's been about a 40% increase in the pace of erosion happening across Scotland. And what that means is that erosion is now impacting livelihoods, heritage, and the overall resilience of communities moving forward in the Hebrides. On Barra and Watersee, the coastline is a mix of rocky shores, sandy beaches, sand dune systems, and mackerel. And while the rocky sections of coastline are relatively stable, the softer coastlines are constantly shifting. And these are the areas that are visible in pink on the map, which is produced by NatureScot's Dynamic Coast project. And as you can see, all 3 of our sites are quite heavily impacted. Borv is slightly different since it's surrounded by rock, but there is a soft inlet there, right where the graveyard is. Muir's tier is focused on managing the coastal change that's happening here with nature-based solutions. These are solutions that offer a more adaptable and cost-effective option than traditional hard sea defenses, and works with nature to protect coastline. and their adaptability and cost effectiveness makes them well suited to a place like Baden-Battersee, where the coastline is already very dynamic and there is, in general, a high reliance on self-sufficiency also when it comes to building climate change resilience. Right now, our main focus is on 3 key coastal habitats. One is marram grass dune systems, which helps kind of build up sand in the dunes, which stabilizes the outer coastal layer and protects cropland and mackerel further inland. Our second focus is on seagrass meadows, which has benefits for biodiversity and carbon storage, but also offers some protection against waves. And then our final focus is on salt marsh habitat, which creates a coastal buffer while also having a high carbon storage potential. And together, these habitats form a healthy dynamic coastline, which offers coastal resilience while also supporting climate change mitigation through carbon storage. But most importantly, the solutions are ones that communities can actively be engaged in and sustain independently over the long term, which is why this project also has a big goal of centering communities in our work.
A collaborative approach. Muir's Teeth is a collaboration between island groups and university partners. We've already heard from Professor Frank Rennie and from David McNeill from Carbon Neutral Islands, who are both partners, and we will hear from Calum MacKenzie, who's on our advisory board. And we hope to continue and build on the links with these organisations by their involvement in our research and experiments. So far, we've fostered this collaboration through various engagement methods. Since the start of the project, we've set up our own events and attended events set up by other people. This is in order that we can explain our project to people and to try and get to audiences that we might not at other times get to. We've done this by, we've turned up at events just bringing along a map, some post-it notes, and asking people for their perceptions on coastal change and maybe what they've seen over the years prior to our project starting. We've held workshops to create windsocks, depict seaweed as cyanotype fabric art, and this has involved the Nautilus Club at the school and people who attended Baden-Battersee Science Festival. We facilitated a public meeting last week to collate a local response to the government marine and coastal restoration plan, and we're working with Garag of Agathua on an ongoing basis. Our textile map, which isn't so far populated, but it's a difference from other scientific research in that this will be one of our ways of reporting on our findings. So it won't just be academic papers, but we'll be showcasing our results. As the project moves along, we'll host craft weekends where local people with craft skills will meet with various experts and they'll populate our map of Baden-Battersee. So we'll depict areas of salt marsh, we'll have seabirds, seagrass, weather stations, previous coastal erosion projects, shells, seaweed, and the weather. They'll all be interpreted into various craft techniques such as felting, crochet, cyanotype prints, and all forms of stitching. And as well as running our own weekend events, we're looking for other opportunities to promote some of our map work. Muir's Teeth has forged some strong links with the young people of the island through working with the science department and with the Developing the Young Workforce Coordinator at Castlebay School. When we have experts visiting the island, we encourage them to include some school visits as part of their trip. Our engineer partners have visited the school to talk about weather monitoring, and they hope to build on this work by teaching the pupils how to maintain weather stations. A group of students from St Andrews University spent 2 weeks of the summer mapping areas of salt marsh. And as part of this project, 3 S6 students were employed as interns. The students visited St Andrews and are maintaining their links with the university. The Nautilus Club pupils were involved in depicting seaweed through cyanotype art. And as Amanda was doing biomass surveys, a student who's hoping to study agronomy helped with the plant selection and the soil measuring. And our work with the school will continue throughout the project. Our next link will hopefully be working with them during Heritage Careers Week at the end of October.
Great. So one of our big hopes for Muir's Tier is that we can show how engaged environmental science can empower communities to build climate change resilience. This was something that we started to experience throughout this summer's fieldwork season, which happened June through August, and we were able to conduct a series of coastal management surveys. So in June, we introduced people to topographic surveys, which took place with a dumpy level, and we talked about the geomorphology of soft coastlines and sediment transport. Then in July, we mapped the extent of our island's salt marsh habitat, and in August, we sampled vegetation biomass throughout Bauer and Matthes's dune systems. And what this meant is that by the end of the summer, dozens of locals as well as tourists of all ages got to be involved in coastal monitoring activities and helped us to build a baseline of information from which future coastal management interventions can take place. But with this said, the contribution of community members in this summer's fieldwork is about much more than the data we managed to collect. What we really want to do with Muir's Tier is to take people on a research journey, which does more than just data gathering. We want to build local knowledge and skills around coastal impacts of climate change, while also giving communities a real sense of agency over the potential solutions that we can bring forward to these challenges. A big part of achieving this will be to have continued involvement of the community throughout the whole research process, so everything from research design to data collection, analysis, and ultimately to deciding what to do with the research results. So our first field season has been really successful in introducing people to what coastal management and coastal monitoring can entail. And our job now is to bring people with us into the next stages of our research journey. So how do we plan to do this? Our most immediate next step will be to establish a community-run weather monitoring network, which will help us understand how weather patterns drive coastal change across our islands. Then we'll be facing one of the biggest challenges when it comes to community engagement in environmental science, which is the data analysis process, which nowadays mostly takes place on computers. So to bring people along with us for that, we've planned a series of artistic workshops where we'll be trying to depict the results from the summer's field seasons in a more artistic manner on our textile map. And then finally, we're looking at different ways of drawing people into the decision-making process surrounding potential coastal management interventions that we can trial in next year's field season. And this will involve both looking inwards and working with the local heritage center and looking at the island's history of coastal management, but then also looking outwards at other projects doing similar things. And we hope to do some project exchanges with a project in Ireland and potentially also bringing people to Barra to see what our coastal change looks like. If you think any of this sounds intriguing, please come and talk to us. We're very open to partnerships and collaboration, and we know that Barra and Matthese are not the only islands in the Hebrides facing coastal change. So yeah, please get in touch. Thank you.
How inspiring was that to see the amount of work that's going on nature-based solutions in Barra Watersee with the community? It's just exactly what we want to see happening. Superb. Climate change, it doesn't just threaten habitats, it threatens a whole range of different things. We could go on and on and on. However, for the next session, Calum MacKenzie from Cornell Ireland is going to come and speak to us about potential impacts on infrastructure. Calum has worked his entire career in the public service in the Western Isles. For 22 years, he was in the water industry before coming back to the council in 2009, where, as of now, he's the Chief Officer for Assets and Infrastructure and has a lead role in preparing for the potential impacts of climate change. The people of the Western Isles have always been resilient stewards of their environment, and Calum believes that working together and with nature, generations to come will thrive in our amazing islands. Calum.
Thank you, David, and thank you for organising this day as well. If I can commend to you the work of Muir as chair, we just heard a bit about it there just now. I had the privilege of being down with them over the summer, and it truly is a community that's doing rather than just thinking. I would commend the work that they're doing to you all. So I'm now going to tell you things that you already know, and then I'm going to tell you things that I don't know. And just following on from Frank's earlier discussion, we need to have some honest conversations. And there are lots of different views out there on what is happening, what's about to happen. So I'll just start by, I'll just make sure, okay. So I'm going to look at the climate impacts now, because climate impacts are nothing new to us in the Western Isles. We've been dealing with them for centuries. I'll then look a wee bit at the predicted climate change. So what's likely to change over the coming years? And then how do we plan for the future? So climate impacts. Coastal erosion we've heard about already. Flooding, we're seeing that happening. Drought, it's happening northeast of Scotland just now. Wildfires, we've seen them here on our own doorstep. Not just Muir burns, but we've seen fires caused by whether it's accidental bonfires or from even just glass being left out in the Lewis Castle Gardens. Landslides, you wouldn't think we'd have landslides here, but I've got some evidence for you that we do. So severe weather damage, we see quite a bit of that, or we have. We'll come into the effects on property and infrastructure, and this question of insurance, that we're finding it harder and harder to be able to insure our infrastructure because of the increased risks. Severe weather disruption to buses, refuse collection, home care. I didn't even mention ferries. So just looking at some examples. So here we have the Lilliclay Dunes. You'll have seen there's been an attempt in the middle of that picture there to block up an area of erosion. That's starting to go already. How do we manage this? Most of the west coast of Uist looks like this. Again, we've been managing erosion for years. So here's a damaged seawall. And this is at the Ice Cemetery in Point in the Isle of Lewis, where you can see just in the top right there, the Eye Church, the coastal defence in front of it, and the damage caused beside it. Again, we've heard about the Borv Cemetery as well. We need to protect our heritage, but how do we do that? Flooding. So this is the township village of Kildon in Uist. This was like, the road was like this for about 5-6 days. People were getting in and out by the aid of the Coast Guard. So droughts and wildfires. Okay, there's a current significant water scarcity in northeast Scotland. That's still in place, and you wouldn't think that in the Western Isles we would have water scarcity. I worked for quite a long time with Scottish Water over here, and there were times during the summer where things were touch and go. We have a lot of shallow sources of water that can be affected by dry spells very, very quickly. It can happen. So again, that's just the point I was making. And again, we've had several reported wildfires over the last few years, which again, you don't think we would have that in the Western Isles, but we do. Landslides. So this is in Leverborough and Harris. So you can just about see the road down at the bottom of that. That just shows you the scale of that landslide. Another one on the base of Harris. So these are significant disruptions. Now, this is caused by, I just talked about drought. This is caused by a saturated surface being oversaturated with intense rainfall. We also had another similar landslide that blocked the main Tarbert Road in 2018. Damage. Probably the most severe damage we've had is the storm of 2005, and particularly through the Uists. So this is an example of the damage caused to infrastructure there. You know, this is what you call severe. There was further tragedy from that event, of course. How do you recover from that? Do you think this will happen again? It's a 1 in 200 year storm. The chances are it'll happen sooner than in the next 200 years. And that's where the complexity comes into that. So looking at the disruption, so first of all, it's services. So I've been involved quite a few times in planning for severe weather. So in the council, we get together with all the services, we discuss the forecast, and we say, okay, what's going to be the disruption? So home care have to make alternative arrangements. Schools may shut, or they may make alternative arrangements. Something as simple as refuse collection, you need to think about, you know, do we go out or do we not go out to collect the bins? These are just some examples of services. You guys will know lots of other services and where the impact may be on yourself, but sometimes you need to know what's about to hit you before you can actually plan for it. This is very reactive planning. We need to get into the proactive planning. So looking at transport, I mean, we all know living on the island how reliant we are on ferries and the amount of disruption that we currently have with the current fleet of vessels. But even with new vessels, the weather impacts our sea transport. All of our goods and commodities come by sea. We use air transport for ourselves and mail, but generally everything we use comes by sea. Planes, I suppose, they can recover quicker than a ferry journey can. And roads, I mean, you can see a couple of the slides there. That's Ballashare Causeway in North Uist, top right. So that's showing probably about 6 inches of water over the top. Passable with care. And then you've got the Bry Causeway. That probably happens about 6 times a year just now, where the Bry Causeway is shut. So, inconvenience possibly. So, what's the predicted climate change? So, warmer, wetter winters. So for me, that might be good news. I manage the winter maintenance, so please, no more bullets. But, I mean, if we're going to have warmer winters, do we have to grit that often? If it's going to be wetter winters, it might compensate for a dry summer. But again, if you've got saturated water, what happens with that? Do your systems have time to recover? So again, looking at drainage, looking at Uist, where there's such a balance there that you really need to consider what warmer, wetter winters will impact. As I go through these, you'll see that it's not just one impact. There's a whole series of impacts that could collide together. So Warmer, drier summers. Great, is it? In some ways, we're talking then about drought conditions, potentially. But also, in the Western Isles, we don't think we need air conditioning, do we? But the way we're building our houses now, so energy efficient, then if you have a 2 degrees increase in summer weather or summer temperature, then it's going to be quite uncomfortable in some of our buildings. You're talking about care homes, hospitals, even offices or work. So do we need to invest in air conditioning? Again, that's going to put energy costs up higher. Sea level rise. So we're looking at approximately 0.6 meters by 2100. That's a prediction. I don't know how accurate that is. I mean, Frank might have a view, Stewart may have a view, Met Office may have a different view. But if we have something to plan for, then if you consider the last slide I showed you with the water on the Ballashare Causeway, you stick another 0.6 meters on that, and it becomes not passable with care, but impassable. For how long? Again, if it's tidal, you've got a chance. But if you're not letting the inland water away, you've possibly got no chance. This is a bit scary when you think about the severe weather events we have just now. We're probably having to plan 4 or 5 times a year for a severe weather event. If we're having to plan maybe every month for a severe weather event, you think of the impact on your services, if you run services. Now, I don't know what the impact would be on services, but I could tell them what the impact is on infrastructure and for them to plan on for that. And a greater frequency of intense rainfall events. We're actually seeing this already. I can think back to August 2017, where there was a weather system that stuck over Barra and South Uist. It didn't move. And there was severe flooding in Castle Bay and South Uist because of that. It moved further up, and then there was severe, that landslide event in Leverborough came from the same kind of circumstances. So if you're going to have a greater frequency of these, in fact, I can just go back 2 weeks ago to a Friday at 5 o'clock when I was sent a video of a rainfall event down in Pollachar in South Uist, where there were streams of water running down towards the houses. And again, that came from this intense rainfall event. So a greater frequency of these, how do we cope? Now, with some of these examples I've shown you, there are things that we have done. So the slide I showed you of Kildonnan, by doing some work at the outfalls and work within the catchment between the council, between Storrs Uist and the Scottish Government, we managed to do some work that's alleviated that. So it's not been so susceptible to that kind of rainfall event recently. So how do we plan for the future? So there is lots of information out there. I mean, I've not gone into any detail there on where the information on climate change came from, but it's out there. You've got really good information available from SEPA and Dynamic Coast on potential impacts on coastal and on inland areas. We have local flood risk management plans, local observations we've heard of before. We're collecting that information now. There's lots of good scientific surveys. There's been LiDAR surveys undertaken recently as well. Modelling, research papers, adaptation guidance, government policy. There is so much information out there. But how do we manage it? What do we do with it? There's so much knowledge out there. And part of this today is how do we capture the knowledge? How do we capture the knowledge in the local community? We've heard about Muir's Cheer there. It's happening quite a lot of places throughout the islands just now, that the local communities have been able to feed into what their concerns are. Unfortunately, they kind of look to an organisation like the Corps and say, what are you doing about it? And I say, well, I don't know. And I don't think anybody has all the answers here. But collectively, we've got the academic and the scientific research. You'll hear from Professor Stewart Angus coming up after me just now, who's got immense more knowledge than I can even think of having. But we need to tap into him, and we need to download him, and we need to get his ideas, we need to get his knowledge together with us. From an engineering perspective, I'm reasonably comfortable with that. But then we need to understand how service delivery is going to be impacted. I don't know your services. I don't know how you work. We've heard of horticulture earlier on today. How is this going to affect horticulture? You know, is this intense rainfall going to impact the way crops are grown? Even the way we manage livestock. And again, there's all kinds of business that could be impacted by this. Again, I don't know your business. You know your business. But you yourselves are going to have to think about how you're going to be impacted by this climate change. So how can we do it? It's about collaboration and sharing. It's about what we're doing today. It's about getting the right people together. It's about what Muir's Cheer have been doing. They've been getting people together. And like mentioned earlier on, we need to have honest conversations. I might have a different view from Frank. Frank may have a different view from me. We all might wonder, well, what's the council doing about the abattoir? There's ways of coming together and having these conversations. Not one way, but collectively. We need to have a structure and we need some governance around what we do. So we can all work together, but we can work together if we know who is doing what. So in terms of governance, it's, okay, say from the council perspective, we will lead on this aspect, and this other organisation will lead on another. How do we pull all that together? So I think we need to draw up some kind of structure. I think that's part of what Climate Hybrids are going to look at. As part of the first part of their project is, how do we structure ourselves? Priorities. We're going to go through the Western Isles, and we're going to identify lots of areas that are going to be impacted by climate change. I showed you Balashare Causeway. I could show you thousands more instances of where there's likely to be impacts on infrastructure due to climate change. We can't do everything. So we need to learn more. So I'll come into my comfort zone and talk about roads. So if I know there's a road that's likely to be flooding in the future, I need to understand more about how often, how deep. So obviously, if a road is going to flood, say 0.5 metre and dissipate within 4 hours, hey, it's inconvenience. If a road is going to be underwater for days, then we need a plan for that. But what I can't do from an engineering perspective is say, right, I'll move the road there and then cause more damage by what I've just done. So as an engineer, I could be quite blatant, I go and do that, but I need the likes of these guys, the academics, to tell me, no, if you do that, you can have this impact on the environment. So we need to be careful about what we do. We need to coordinate what we're doing, and we need to prioritize what we do. So what are the challenges? People and money. So we would all like to do a lot more about climate change, but we all have lots of priorities to deal with on a day-to-day basis. So we need to collectively make the most of what resources that we have. Money is always an issue. We could have all the money in the world and not manage everything we need to do about mitigation and adaptation in the Western Isles. So we need to adapt. We need to be able to change how we do things. And again, I'll use Muir's Cheer as another example, looking at how we can use nature-based solutions to help us. Skills. As I mentioned earlier on about downloading people, we need to transfer knowledge. We need to gather knowledge. We need to equip the next generation. Now, talking to the youth, the young ones here, some of us are reaching the end of our careers, possibly. What I'm seeing just now is a huge gap in people wanting to get involved in engineering. So I'll go back to my Scottish Water days and just use some examples there. You will all turn on a tap now and you'll expect water to come out of it. You expect it to be clean. Where does it come from? Where's the source? How sustainable is that source? What do you need to do to treat it? And what's the waste product from it? You don't think about these things. I want you to think about these things. I'll go on to the dirty subject now. Everybody goes to the toilet, flush the toilet, and forget about it. Well, it was my job once upon a time not to forget about it, but to deal with that. So whether it's cotton buds or whether it's anything else that goes down the toilet, there are treatment plants there that wasn't me, that need to be maintained, and you need to know what happens with these waste products. Part of my role now is waste management here in the Western Isles. Challenges with that as well, because we've become such a disposal society. And it was really heartening to hear about things getting recycled earlier on. We need to see more of that. And we need people, we need the young ones to take responsibility for these things. So going forward, there is a lack of people coming into engineering and civil engineering to understand these processes. Because one of these days, somebody's going to have to build another bridge. Somebody's going to have to build another road. New buildings and how we actually manage them. I mean, you see conflict just now. You're building, new buildings are so insulated that, and we talked earlier on about needing to put air conditioning into them. But yet our old buildings, if you insulate them to that nth degree, they're going to be full of condensation inside. You need to think about what you're doing. And we need to think about how we reuse in our old estate. I'm putting this as a challenge. I think there's going to be complacency over climate change. People will think that we're overstating what the impacts would be. I've seen them over the past few years. There are already impacts. If even there's a doubling in the number of storms that we have, there will be impacts. And again, is it someone else's problem? You know, some of us are getting older and we're thinking, next generation will deal with that. We can't afford to do that. We need to help with that planning. We need to transfer these skills. We're going to have to adapt and have difficult conversations and difficult decisions. It may be that there are bits of infrastructure that you can't save. There may be people's houses that come under threat that you can't save. You need to work with communities. You need to understand what happens when you lose a bit of your craft, or maybe all of your craft. How can we adapt to that? So this is maybe for you to think about. What does it mean to you individually? How would it impact you? And how big a priority is climate change to you? So in conclusion, we're currently dealing with the climate impacts. We need to better understand future impacts. We need to structure ourselves and work together. We need to develop robust planning to protect future generations. And we need to adapt. Nature will change our environment. I stole this. I was talking to Stewart a couple of weeks ago, and we came round to people need land, but land needs people to manage it. If we don't manage our land, then it will disappear. We will not have it as a commodity in the future. Thank you.
Calum, thank you so much for that sobering presentation on the challenges that lie ahead from an infrastructure perspective. The next speaker that I'd like to introduce to you is Professor Stewart Angus. Stewart joined the Nature Conservancy Council in 1978 when he was appointed as the Assistant Regional Officer in Sutherland, when he got involved in work around afforestation in the Flow Country, which is now a World Heritage Site. Stewart moved to a similar post in the Western Isles in 1985, and in 1989 he made a really bad decision because he gave me a job. Thank you, Stewart. On the formation of SNH, Stewart became the first area manager for SNH in the Western Isles. And then he went on to work in our advisory branch, as it was then in 1997, where he grew his long-standing interest in Machair as a specialist in coastal ecology. In addition to dealing with development casework and monitoring some really significant development casework, Stewart's role has a considerable climate change element, and the approach is very much on an attempt to gain understanding of the way that the wider ecosystem functions. Stewart has published 2 books and numerous scientific papers on the Outer Hebrides, again with a particular interest in the Uist Machair. And Stewart was awarded an honorary professorship at Heriot-Watt University in 2015 and continues to work closely with Uist communities on climate change impacts. So Stewart, can I invite you to the table?
Vestergaard, it's nice to be back. Well, I'm going to begin by outlining some of the challenges that face us in the years ahead, in outlining how the environment works or how we think it works. But it will have to be very short and superficial. If you want more information, there is an online talk that lasts over an hour on the Scottish Wildlife Trust website. So you can download the YouTube video of a talk I gave there that goes into considerable detail. Scotland has been addressing emissions in what I think is an exemplary manner, which it's very pleasing to see is very closely followed here. But Scotland's a small country, and even if we were emitting a lot of stuff, our proportion of impact on climate change would be quite small. And what we have to remember is that what really matters is global climate change. And as well as emphasizing our own contribution to this, we should be looking at how global climate change could affect Scotland, bearing in mind that the country's infrastructure and settlement are primarily coastal. However, even if we achieve global net zero, and I wish I could be optimistic about this coming soon, sea level rise is going to continue for centuries. This being the case, we've really got to start thinking about adaptation now. It's not something that's happening somewhere else or something that's way off in the future. It's happening in the Western Isles, and it's happening now. What form is this taking? Well, if you look at the map on the right, it was prepared by 2 of my colleagues, Alistair Rennie and Jim Hansen. And the one on the right is recorded sea level rise. I should emphasize that when I talk about sea level rise, I mean relative sea level rise, because the level of the land changes as well. And you see that in the Western Isles, relative sea level rise is running at about 6 millimeters a year. It doesn't end there. Rainfall patterns are already changing, and as we've heard, are likely to change more. We're already seeing wetter springs and autumns and drier summers. That has, or can have, a profound impact on Machair cropping. Some of the scenarios envisage much, much higher winter rainfall. So that is the climate change background. How does this impact the Western Isles? Well, we're looking here at Uist, because basically, if you can figure out what's going on in Uist, it's easier to understand what is going on elsewhere on the coast, not just in the Outer Hebrides, but throughout Scotland. We're looking at a low-lying, exposed landscape, much of which consists of Machair and loch, but there used to be a lot more lochs. We've reconstructed the loch network that used to exist in southern South Uist, and there used to be a single loch stretching from Dalborough right up to Bornish, possibly with a canal connecting Loch Bornish to Loch Turnish. 13.4 kilometres long. That loch was drained, and if you look at the bottom loch, it was called Loch Dalabrog, though other names have been used, and that loch is now almost gone. And today, if you use LiDAR imagery, which is a way of measuring land elevations very precisely, you see that the loch bed, represented here by this pale green colour, is extensive and low-lying. And when you've got low-lying land, I'm going to come back to that, I'm getting ahead of myself. If you look at the dunes here, represented by the darker green and the orange and yellow, you see that the dune ridge dwindles to almost nothing in terms of height and breadth as it reaches the shore. Classifying the land levels here, you see that everything coloured here, apart from the yellow, is actually below the level of mean high water springs. If you add the yellow, that takes some notional account of the bit that isn't quite covered by the mean when it's higher than the mean. So very extensive area of land behind this narrow dune ridge, which is actually below the level of the sea a lot of the time. Alistair Rennie has also modelled this in an oblique view, and he's exaggerated the vertical axis to make this more obvious, but you see where that dune ridge dwindles away to almost nothing, there is a lip. Every time the sea takes a chunk out of that lip, it not only removes some land, it removes some elevation, making that low-lying area behind that bit more vulnerable. So Tiree might be a place that's called land below the waves, but in the case of Tiree, it's an optical illusion. In Uist, it is all too real. For much of the tidal cycle, when the tide is in, extensive areas of southern South Uist and western Benbecula lie below the level of the sea. That being the case, you need a really, really good barrier between that land and the sea, and for most of the coast, that barrier is the dune ridge. So going back to the map we looked at earlier of sea level rise, we're looking at a rate of approximately 6 millimetres a year. In their paper, Rennie and Hansom said that once you get past 3 or 4 millimetres, you're looking at widespread reorganization of coastal landforms. What does that actually mean? Well, we can look here at a historical document of 1389, a papal charter. And if you look at the last 2 lines of this, it describes 4 penny lands in Illarey, that's Balashir, between Husebost and Canosorrel. We don't know where the last place was or is, but the landscape we're talking about is this. Balashir, as many of you will know, means East Town, suggesting that at some stage there was a Balashir, a West Town. Well, in this watery landscape, there could have been more land than there is visible now, and that is suggested by this cluster of rocks, which is called Sgir Husebost. And saddle querns have been taken out of here, strongly suggesting that this is actually the former town of Husebost. It doesn't end on the land. This is a highly complex situation. Offshore, we see a very shallow seabed. And despite the seaboard of Uist being largely sandy, that doesn't actually extend very far offshore. It's a rocky seabed, though there are pockets of sand. That rocky seabed exerts friction on waves, thereby removing some of their energy. But as important is what grows on that rock. And it's a kelp forest, extending about 7 kilometers west of Uist. And the stipes of the seaweed, which is called Laminaria hyperborea, or kelp, the stipe or stem is stiff but not rigid, so that when the waves pass over this, they move it, and the movement requires energy. That energy is extracted from the waves. And in normal circumstances, we're looking at the top diagram here, where the wave base interacts with the kelp and the energy is removed. Perhaps as much as 80 or even 90% of the wave energy can be removed in this way. When the sea level is elevated, and I'll go in later to talk about why it becomes elevated, but it could be as simple as high tide. The wave base disengages from the kelp, and with that, the removal of wave energy stops happening, so that a sea that is vertically higher than usual also arrives in Uist with more of its energy than usual. And as sea level rise progresses, that disengagement is likely to happen more frequently. We've heard about frequency of storms, possibly the frequency and severity increasing. For this scenario to operate, we don't need to have more frequent storms or more severe storms. We just need more storms for the impact of that same level of storms to be more severe, because more wave energy is hitting Uist. So we have this situation where we have low-lying land separated from a higher sea. The dune ridge is critical in protecting that low-lying land from invasion by the sea. But that dune ridge has weak points. We've already seen one at Kilfedder. The sea actually comes round islands like Balashir and threatens the east coasts. It gets in at estuaries such as Homor. It gets in at lagoons. Uist is very heavily drained. These drains are critical to the dispersion of rainwater. But remember, your land is very low-lying. Water won't flow uphill. If the sea is higher than the water on the land, the water is going to stay on the land. You will only get a flow of water to the sea when the tide's out. The problem is, part of sea level rise is the level of low water increasing, so that there is going to be less time during the tidal cycle for that discharge of rainwater to occur. We reckon the first drains were built in 1744. In fact, built as a canal. The Straum Jarach in South Uist was probably built as a canal to link Old Loch Dallabrog with the Minch. Since that time, mean sea level has risen over 1/3 of a metre, and it's still rising. Now, I talked about drains, and I've also mentioned canals. Both are still there, both still functioning. Obviously, the canals are no longer carrying boats, but they're still there. This canal system exists on the Ollie network in South Uist and links Loch Ollie with Loch Kianavai, looking south here towards Loch Kianavai. Some of the drains have valves on them. This is open through Mishkeri in North Uist. The idea being that the valves close when the tide comes in, preventing salt water getting into the loch, but opening when the tide goes out to allow the fresh water to exit the leak, so that behind these drain covers, behind these valves, you often have saline lagoons with brackish water. Some of them, including one of the largest, the Roe Glass, have no valves, just a grill. And this is the old one. I know from Calum that this one's been replaced, but it's been replaced by another grill, not a valve, meaning that at high tide, the water flows up the Roe Glass 1.4 kilometres into Loch Kildonan. So drains are critical in removing floodwater, and they operated properly and rapidly in 2005, except when they were blocked. Floods aren't just water. Obviously, they have level, but as anyone who's around 2005 will know, they can also have energy. And the more energy they have, the more sediment, the coarser the grade of sediment they can carry. They can carry sediment isn't the problem, though there is an element of transfer of sediment from perhaps where you want it to somewhere you don't want it, but the problem is that when the flow of water slows, the sediment drops. They have chemistry. Water entering the Macher systems is acid. Water leaving the Macher systems and flowing into the sea is alkaline. There are fundamental chemical changes as the water moves through the Macher, but you're getting very rapid transfer of different water chemistry there during a flood. You've also got to remember that salt water gets into this network. So you also have salinity becoming a problem in floods because salt kills any animal and any plant that isn't adapted to deal with it. Things live in that water. You don't really want some animals and plants being shifted around the islands, especially if they're aliens, like, for example, Canadian pondweed. Worst of all, from the human point of view, they can carry disease because of the flooding of septic tanks. There are 4 major water catchments in South Uist, and they are separated by very low-lying ridges. The flood in 2005 reached 4.6 metres. Mean high water springs is just over 2 metres, so you're talking of 2.5 metres on top of a mean high spring tide. All salt water because there had been no rain in the last 24 hours. What you have to realize is that if a flood were to reach 5 metres, only slightly higher than 2005, the topography will no longer contain the flood. You will get these 4 catchments, or 2 or more of these catchments, merging and landscape scale flooding. The level of environmental linkage in Uist is extreme. You've got the kelp offshore, surface water, subsoil water, because the water tables are critical to land use. Perhaps with connectivity exaggerated by old canals that we don't actually know about, with the legacy of human history superimposed on that. And we conservationists are acutely aware that what we are attempting to conserve here is a managed landscape. And where every habitat is connected like this, we call it a meta-ecosystem. So all these habitats acting together have a spatial connectivity, but Uist goes one stage further in that it adds a socioeconomic element and the legacy of all the canals and drainage. So I've written a paper which actually suggests that Uist has something beyond the meta-ecosystem. When you get a flood, whether it's a marine flood or a freshwater flood, it's usually associated with an atmospheric depression, a cyclone. Low atmospheric pressure raises sea level by 1 centimetre for every millibar, or strictly speaking hectopascal, below standard pressure. And the flood of 2005 raised sea level by 69 centimetres on the basis of atmospheric pressure alone. So the greatest likelihood of flooding, whether it's from the sea or from rain, will be at a time when the sea level is at its highest, and the drains are functioning at their least efficient levels. So the meta-ecosystems connect all these habitats. We have the superimposition of socioeconomic factors and the historical legacy. So this gives you complex connections. We need to know how they work. And my mantra for working in UIST and communicating with communities is that everything is connected. So the solution might be to link the knowledge from these three sources, because if you add them up, they add up to something that is greater than the sum of the parts. What sort of thing could we be talking about here? Well, we could learn about hazards. This, for example, is an old rubbish dump. It's quite old. This is an old slide, and you will see nothing there today. There's more than one of these in UIST. Who knows where they are? The community knows where they are. The word resilience gets kicked around. Well, let's look first at the natural environment. We're dealing with three types of outer exposed coast. The hard rock, Lewisian gneiss, 3,000 million years old. What could be more robust than Lewisian gneiss? Okay, this next slide isn't Lewisian gneiss, but it's a rock. This is CnES in Shetland, the Grind of the Navar. And we're looking at a rocky cliff top where waves have excavated rock from the bedrock and piled it up as a wall of rubble, a storm beach behind. Now, it's surprising enough that waves can do this to solid rock, but more surprisingly still is that the rock we are looking at in this slide is over 40 feet above sea level. We have shingle. Not a great deal of it by the standards of the UK, but it's significant, especially as a line in front of the dune ridge. Shingle is important because it's heavy and it's movable. And when the waves are moving this shingle, they're using energy which is not impacting elsewhere. Then we have what is euphemistically called soft coast. Strangely, this is actually more resilient than hard coast because it moves. This is called mobile dune. The dune ridge where the marram grows is called mobile dune because it moves. It adjusts to things like sea level rise and wave action. Yes, it will lose chunks in a storm. What people tend to notice less is that in the wicks following, that sand is replaced. And marram extends its roots to bind this sand, which is why grazing animals in the dune ridge are a bad idea, not because they graze the marram, but because their hooves destroy the rooting system. Mobile dunes can be managed. I just mentioned the livestock element. Now, you would think that as sea level rises, the dunes rolling back would be an issue, and they are, because this is the way they're adjusting and making the coast more resilient. The problem is they're rolling back onto people's crofts. That land is hard won. People don't want to be losing their land, but it's a difficult message to communicate. But it might be that the crofters are facing a choice between accepting some loss in this way and accepting a much larger loss by way of marine flooding. As I say, the dune ridge can be managed, and by managing it, you control the rate of movement of roll inland. The problem is if two adjacent townships operate their management differently, the dune ridge will move at different rates, and the join between these two townships could thus become a point of weakness. And if the sea were to break through, it wouldn't just flood one township because you have a linear depression 13.4 kilometers long. So coordinated management is essential here. You can look at resilience differently. These islands are resilient, but let's not kid ourselves. Resilient doesn't mean invincible. It is entirely possible that there is as much resilience in the community as in the land. We are fortunate to be able to call on an initiative elsewhere in a similar type of environment called the Coastal Communities Acting Together that brought together community and academics on the Fink coast of Ireland and Pembrokeshire. And they identified 4 main issues, and it's interesting that this was the community perspective. Firstly, nobody took responsibility for the commons. I don't think we have this problem. We all take responsibility for the commons. Silo mentality was used as an excuse. It was always somebody else's job to do something. Again, we don't have this problem. When we go into a room in the Western Isles, we all own the problem. We are all part of trying to get a solution. They felt their culture had been ignored. I don't think there's any danger of the culture being ignored here. It is far too many champions. And lastly, staff turnover. I would have said that staff turnover is not really an issue in these islands, but of course our area manager then goes and moves to lofty positions in NatureScot. But I think all organizations operate a policy of encouraging staff development because that's the way you get the best staff in the long run. So where does NatureScot fit into all this? Firstly, a high percentage of this land is designated, it's legally protected for its environmental quality. That means that in order to advise and plan, we need to know how the environment functions, especially with regard to climate change. And the research we've conducted in this sector turns out to be of value to the wider community. However, and this is where it can get problematic, because we have been very much to the fore in this climate change work, we have been perceived in some quarters as having responsibility for work on the ground, not us Gov. It's not the silo mentality. We're simply not involved in this. Our role is advisory, but we are very keen to advise wherever requested. There is research. This is the most recent of a series of papers on how UIST functions, and this is working with Professor Jim Hanson of the University of Glasgow, with whom I've written quite a few papers. And it builds on a research base established by an interreg project called Coast Adapt, run by the Corla. And the skilled leadership of David Muir, who is still in UIST, though he's retired. And it takes the research and attempts to build the foundations of a strategy for responding to climate change. And it has been developed in close consultation with the community, but not in any formal way. This document has zero status other than as a peer-reviewed example of research. Now, even with extreme environmental change, we're going to see habitats of UIST that are still of value. For example, if that low-lying macher, which used to be at the bottom of lochs, becomes a salt marsh because the sea has broken through. There is an element among ecology approaches of saying, so what? Well, it isn't as easy as that, because there is one exception. Macher cultivation. We have to conserve macher cultivation to retain the biodiversity value of macher. And macher cultivation isn't just about land use, it's about socioeconomic linkages, which in turn relate to employment ability in the islands. And of course, the whole thing depends on cattle. It's surprising at a climate change conference to hear so many people bang on about the high value of cattle, but there it is. These cows, and they might be farting and belching greenhouse gases like there's no tomorrow, but they're also maintaining a very high value environment and the community. So climate change, as has been said several times today, is nuanced. Going back to the interconnectivity, we're dealing not just with natural habitats or even managed natural habitats, but together they form a cultural landscape. The drains, and of course now the infrastructure, give you an engineered landscape. And perhaps, not that there's no perhaps about it, sometimes problems with an engineered landscape require an engineered solution. That's a fair argument. And we have to take cognizance of the legacy of history and the way this landscape is linked across sea, shore, land, and water. When you have this level of connectivity, you have to be aware that if you change one component, you can change a lot more. There is actually a word for getting it wrong in these circumstances. It's called maladaptation. By doing the wrong thing in response to climate change, you can actually create more problems than the climate change itself. In other words, you really, really need to know what you're doing. And whoever is taking decisions has to be well informed. So, where does this leave us? How do we treat this problem? I'm just throwing a few ideas into the mix here. They're my own ideas, but they're derived after long and many discussions with local people and organizations. But ultimately, they're just my suggestions. Remember the connectivity again. How about local people taking decisions as far as legal circumstances permit? Which means that local people also have to take responsibility for these decisions. And people like me merely inform this process. We have a background where much of UIST is owned by the community and managed by the community when it comes to land use. Now you hear about the tragedy of the commons, where nobody takes responsibility for anything. We're the opposite. We all take responsibility for everything. And we largely avoid the silo mentality, but you have to remember when it comes to funding, there are legal constraints on how we can spend money. Instead of looking at the commons as a problem, why not regard the commons as the solution? You can't force townships to coordinate their approach, and who would try? But equally, nobody can stop communities deciding to do this. You can have local decision-making using powers you already have, but coordinate these. Get advice to make sure you're well informed, and that way you can take responsibility instead of blaming other people. We're back to our three sources of information and knowledge here. And I stress that within community, I include young people and businesses. They're not separate from the community, they're integral parts of it. So how do we get this right? Here I introduce the dreaded word consultants. The problem is that the three community agencies and academics have no resources left to spare. You can throw money at this situation, but money doesn't solve the problem because you still have the problem of how to spend it. Who's going to ask the questions? Who's going to write the contract? Who's going to manage the contract? We're struggling as it is, all of us. But the legal obligation here is on the Corla, and we all know how the Corla is struggling to meet legal obligations it already has. We can come back to our connectivity. The level of complexity here is such that any consultant is going to have their work cut out just understanding the nature of the problem. Even understanding the nature of crofting can be a major problem if you live in the central belt or parish of thought even further away. Anybody who's worked with consultants in the Western Isles will tell you that it's desperately frustrating because you could brief them at great length. They're charging you for their time, making good their knowledge deficit using your knowledge, and you're paying the bill. So, is there another way of doing this? We can help by informing the context. But we have to remember that adaptation can have a profound impact on people's lives. That being the case, we need to involve people in planning the adaptation. It might also need a very long lead-in time. If you're planning, for example, to move a road, a coastal road, from one side of a village to the other, you talk about major disruption. All sorts of things are in the wrong place, not least the access to the individual houses. But getting community input isn't straightforward, and I dread the thought of people turning up with clipboards and questionnaires. I'm not convinced that works. It makes it look like people have consulted the community. So I've said spending money takes time, and we need to figure out where this is coming from. Our three sources have very little of this commodity. So how do we find a way around it? We come back here to consultants. Perhaps instead of getting the consultants to impose something on us, admittedly with some input via questionnaires or workshops or whatever, instead of doing that, we get the consultants to bring the three groups together and bring their knowledge into a single document where they bounce ideas off each other and the consultants merely write it up, so that what is delivered to the corner as their coastal adaptation plan is actually a plan owned by, devised by the islands, by all of these three categories of people. So we have a way of doing things differently here, and I can do no better than put it in the words of these great island philosophers, Dr. Pete and Professor Diesel. That's the way we do it in the Western Isles. But time is the difficulty here. We are faced with a situation where the sea is rising. Winter is getting wetter and possibly will become wetter still, when the drains are becoming less efficient. And the expertise we so desperately need for this approach is getting on a bit. The time is now. Thank you.
Thank you. I've got your watch, Stewart. Three incredibly thought-provoking presentations for you to consider. So much to think about there. We have eaten into our question time. However, I think it's important that we have the opportunity to ask a couple of questions of the panel before we move on to the next part of the programme. Who would like to ask? I'm only going to take 3 questions at the most. Frank, someone got a mic? Or can you shout? Right, here's the mic coming.
One quick response to Stuart's poser and one question for Calum. I think, Stuart, rather than give the money to consultants, you give the money to embed an expert base within the community cooperatives, between the community land trusts. They've already shown that they can do this if they have the resources. Galson's gone from no people employed to manage the estate to having 18, 19 people now and doing the jobs of all these different things there. So you can actually embed a ranger, a land action specialist within the trust. And that recycles the money within the community. A question to Calum. This is a genuine. During COVID, the ORIS, the Galson Trust, actually set up WhatsApp groups for help within the communities and whatnot. And just a few weeks ago, we had a global alert on our phones from whatever it was, some nuclear attack or whatever it was. Is there any way that the Corps could actually use that technology to gather assistance, both the issue warnings about when storm surges, brae closures, whatnot, but also perhaps a different app to collect information about where roads are flooded deeply and so on and so forth? I think the technology has a great potential for this.
Yes, CEPA actually have a flood alert system that they can alert communities. You sign up to it and you'll get that warning. So you'll get a potential brae closure, Ballashare Causeway closure. That exists just now and you just sign up to it. Dynamic Coast as well have on their website a means of people inputting any issues to do with any coast. If they're seen any coastal erosion, they can take photographs, they can upload any information on it. The Climate Heritage site also has that as well. There's also a worldwide site that gathers that as well. Muir's Cheer have a snap point in the Battersea, which collects that. So there's a host of ways of collecting information. But to come to your point, there is so much more that we can gather. I struggled actually to go and find and research what time and where all these incidents I had examples of up on the screen. I had to go and do a bit of digging. It should all be in one place. So I think it's really good to actually collate all the information we can and share it, because it'll mean different things to different people. So I think the sooner we have one place and one interpretation, the better.
Thank you. Any other questions? There we go, in the middle.
Sorry, I'll be really quick. Question for Calum. Again, interested in seeing the impact on infrastructure, because there's a lot of planning that has to go into that. Is there any specific scenario that you're working against, like representative concentration pathway, that you're scenario planning for?
No, I think it's that complex. I mean, you've heard a lot from Stewart today. You've heard a lot from a lot of the speakers about what's going on. The difficulty I have is we don't have that complete information or that prioritization to say, well, this is the worst area, we need to concentrate on that. It's good that you're seeing different communities doing different things. Communities can learn from each other. I think, as I said as well, one of the difficult things for us is, although we've got good information from the likes of Dynamic Coast and from the CEPA flooding maps, it doesn't tell me what the depth of flooding would be and for what period it lasts. That's where we need to get to. And I think it's more about experience. And as we gain that experience by these events that are happening just now, it's then helping us plan for the future. It's very difficult to take a scenario and then plan for that, I think, if that's where your question is going from. And another example on that is that we have done quite a lot of modelling on certain areas, the South Ford area in US in particular. And what we found by experience over the last 20 years is that the coastline hasn't behaved as we thought it would, or as we modelled it would. So a lot of that needs to come from the experience, what people are seeing happening, and building towards that as well. There is a place for modelling, but I think it's only a guide. And as we heard as well from others, there are lots of people who have lots of information that help guide our journey, so to speak. So we're all in it together, I would say.
Thank you. We'll take one more question. We don't need to take one more question. That's fine. Well, can I ask you all just to thank all of the speakers in that session? Thank you very much.